All right, friends, let's look at excuse me. Let's look at the last part here of series on combination permutations. So let's look at the case where in the combination basically where ordering doesn't matter and repetitions are allowed. So for this particular case, we'll assume our set size is A, B, and C, and which is n is equal to 3, and let's say we are going to choose 3 out of that. So subset size would be 3. So one thing we know is that, from all our discussions, is that in combination, each branch has to be unique. So if I choose A here, right? So uh, I can go ahead and choose from A, B, or C, uh, and but the other branches, right, like B, so uh, they can't choose A. They have to start with B, and we are starting with B here because repetitions are allowed. So I can choose from B or C, and here, if I have C, then I can only choose from C. So each of these gives us unique branches. So this would give us a branch from A. So it's give us a branch starting from B. This gives us a branch starting from C. So for this case, we can have three branches matching out because we have three choices, and of course A is repeatable. So we can have A, B, and C. And similarly here we will have so this is A and A branch, and then since our subset size is 3, so we'll have three branches to give us A, B, and C. And similarly for B, like we have here, so we can either give us B or can either give us a C, and eventually C just can give us C. So this is a branch with AB, and this is a branch with AC, right? So like we saw earlier, B can only either give us a B, another B, or it can give us another C, right? And for the choices for C is just C, or for this one it is B or C, right? So because I can choose B again, and this one C, I can only choose C again, right? So this is a branch CC. So this one is a branch B, and this one is a branch BC, right? So the C branch eventually has only one choice, which is C, and the B can still branch out to be either a B or to be a C, and so this is where our recursion says that we have reached our uh, subset size. So we return, basically. So we return from here, and then we can choose a C from here, and then we return. So so let's look at how many combinations we got with repetitions. So we got with AA we got three branches. So with AA we got A with B and C. So with we have three unique subsets starting with AA branch, right? And then with AB we have two subsets as well, which are B and C. So we have B, and then we have A, B, C, right? So notice that all of these are unique. And then with AC, we have one branch, which is ACC. So 1, 2, 3, 4, 5, 6. So we got 6 so far. Then with BB, we got two other branches. So with BB, we got a B, and we got a C. Right? So with B. And then we got one with BC. Right? So with BC, we got C, and this would give us eventually a branch which would be C, C, and a C. So we count them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total we got 10 possible subsets, unique subsets, which are of size 3 from these particular input, n is equal to 3, where repetitions are allowed. And notice each of these are unique. That means no two are duplicates here. Now, the tricky part is coming up with a formula that would define this particular uh, uh, subset size, so to speak, subset size or string or vector of subsets that defines this particular combination. So the general formula is k plus uh, n minus 1, so factorial that divided by uh, n minus 1 factorial times k factorial. Now, how do we get that? Probably a discussion for another video, but this is the case when the ordering doesn't matter, which is a combination, and repetitions are allowed. Okay, so what is a k here? So k is 3, and then we have n as 3 as well. So 3 plus 3 minus 1 factorial, and then we have n is 3, 3 minus 1 over 3 factorial, factorial over factorial. So that would be 5 factorial divided by 2 factorial times that's 3 times here multiplied 3 factorial. And we have seen that that boils down to 5 times 4 times 3 factorial divided by 2 factorial times 3 factorial, and these two cancel out, and 2 factorial is nothing but 2, which is equal to 10, which is what we saw here. We got 10 this. And programming this is trivial as well. So we have our for loop, right? And we start our int here, and we know that it's a combination. So for the we have an offset, right? So an offset, and then that is right. Oh, sorry, we take it back. Off. So for loop would look like uh, for loop would look like. So we have int I equals offset, right? And I less than n plus I, right? Now, what are we adding to partial every time, and how are we incrementing the offset? These are the two things. So how do we increment the offset? So we observe here, so at every offset we pick the first element, and then when we are nearing the uh, the subset size, then we go and increment our I, and then we pick that, and then we pick the other one, right? So for this particular offset, which every time the offset actually remains the same for the first one, right? So here we would have a second. Give me a second here. All right. So for partial, I'm going to add what is currently my value of I, and for I, I'm supposed to choose 0, and for my next iteration, I'm going to just keep it at I, right? So that makes sense. So if you look at this this branch here, so I'm not incrementing the offset, so it is going to be A. That gives me A, and then when I'm done, then I return, then I increments, and then it says the partial will be S plus I, which is B, and then I pass in the first offset, which would return, and then I collect AA with C, which would give me AAC, and that would give me, and then this for loop would be done because I is less than it would be greater than n. And then I return. And so now for zeroth offset, I would have done this left branch. So for the first offset for this particular iteration, now I have A in my partial, and then I would be incremented to B. So I would select B. So that would be AB, and then I would pass I again, which would be uh, the uh, which would be uh, which would be I. Sorry. So it has to be, this has to be offset T, right? This has to be offset, and the offset would be 0, and so uh, so this would be offset 0, and I doesn't change. So now the offset would be collected here, which is 1, and it will start from 1 and 1 and 2. So it will connect 1 and 2 here into AB. So AB will connect ABB and ABC, and then uh, this would be done, and this would return for this offset back. And now for this particular offset, it would be I will be equal to 2 and add AC. So A with C, and then I'll pass in 2 again as an offset. It will start with 2, and it will pick up another variable from the C, and then that would make it ACC. So that makes sense, right? So we can take a look at it real quick in the program.